Dear customers, dear colleagues, as requested, I'm recording today a presentation video for Smart Balancer 4 field balancer from Schenck with a new rotor model. We have the home screen here with saved template for two-plane balancing. On the left side we check the measuring points and have the live values, vibration, RMS and 0 to peak. Of course, before we have put in the reflection mark and have the live values on the screen now. We save the project to have the possibility to return to it anytime and see all steps. Now we have initial run, initial and balance. We have the possibility to go deeper to the FFT and see peaks. Example, here we have 1490 something running speed. This is 25 Hertz, and yes, as we see here, we have the unbalance, but we can show also the harmonics, and on the right side, the peaks here, the amplitude, several different visualizations are available with the Smart Balancer 4. So next step is to check, are we doing correction in one plane or two plane? We will adjust to two plane balancing A and B. Go further, we apply the changes. Here on the right side you see that we have a split. Channel 2 is plane A, channel 3 is plane B. And as you can see here, we have a rotor positioned between the pedestals, so we change the picture. This is actually only for the visualization. We have several positions for correction, in this case 12. So we will change it as well. So plane A and plane B. This can be different on the left or right side, plane or one plane or two plane. So next step is the trial run or calibration run. We put to position 1 in this case, 9.9 gram. This should be, trial weight should be enough to see a difference between the first run and the trial run. So we put it on position 1. And in this case, or if you do free balancing, so polar balancing, if you put, for example, a trial weight on 0 degree, this defines your 0 for later correction proposition angle. So we perform trial A run, so on plane A. Yes, we remove the mass because we are putting the same weight on the plane B as well on position 1. As well, you'll see here the deviation from first run to the second run. And as well, here we remove the trial mass and have the correction proposition here on the screen. This is what we do now. I'm putting exact proposed values and This is the result. We are close to the center. But I'm not very happy with the results. I like to be better. So we do. Now we have here the FFT. This is very helpful to have the FFT and the polar plot on the same page. Yeah, we keep it now, the correction mass, and go to the second correction step to improve. This is the second correction step, and as you can see, this is much better. Now, this is what will also be confirmed by the FFT. As you can see, in 25 Hz we reduced the imbalance. Of course, systems are different. In this system, for example, we can show also the coupling problems the machine has, or coming from the bearings, so we have harmonics here. But the unbalance is solved. So usually if you have only the unbalance, you have also the overall vibration low. Yeah, so you can continue, of course, with correction 3, but we are happy here with the results and can print out the protocol. This is saved on the flash drive of the Smart Balancer 4. What I would like to show is also the run out, the cost down or run up feature of the Smart Balancer. Here you have the balancing steps. And now we will add also cost down. This is the same file we're working with. So adjusting the start speed and stop speed. Now we accelerate, and when we turn off the machine, so on the next page, yes, here, so we see this process bar, and if we stop the machine, it starts the measurement. When we reach 300 RPM, as adjusted before, automatically show us the results. Yeah, we have the possibility to see the Bode and Nyquist diagram, also several different visualizations, and waterfall diagram as well. We have here, coming back to unbalance, we have can also adjust the tolerances as per ISO standard, and having them on the protocol, we connect the Smart Balancer 4 to the PC via a USB-C cable and see it as a USB stick, for example, here as a flash drive. Go to reports and open the report. Yeah. Of course, you can change your logo on the right side, the address, company name, and so on, operator name, And as you can see here, this is the balancing tolerance. So we have adjusted 6.3 and have 1.17, so we are good. We have polar plot and the FFT, as well as all the steps we did and the final result. Initial run, FFT, and after second correction. This is a PDF for the print. Now I like to show you the function that if you save a file, you have the coast down and the balancing in one file. You can go to the steps anytime. Smart balancer is put into a hard shell box with rolls for better transportation.